So while Yvonne is going to bring this up, let me start. I was back at IBM until 4 months ago, and I spent a lot of time interacting with massive amount of customers, enterprise customers as well as HPC customers. And so over the years, I always interested working on GPFS, ask people, well, what do you actually expect from storage systems in the future? So, and given that I also was involved in a lot of very complicated problems in the field, working on the architecture on GPFS, I obviously heard a lot of people, always screaming, crying about things that don't work and should work better and things that should be natively part of a storage system and so on. And so it was kind of an interesting continuation when I moved to DDN and was asked by the leadership team to help, figuring out what should we do going forward. So what are the interesting things people look for? What are the big challenges that we as thought leaders really should put into? And so I actually like this picture, so I put this into a chart. I don't know who did it. I couldn't find any trademarks for it, but I like the pictures that you kind of look into the future and see what's going on through this interesting lens. And so basically when you're talking to customers, you get a very, very wide variety of things that people talk to. And so collecting this data, what we were trying to do, and James was very helpful getting this chart deck together with me, was essentially trying to figuring out, can we see clusters of very, very large problems that people see in the usage of storage in general. So this is not necessarily just, file systems, not necessarily parallel file systems. This is in general, what are really the big challenges people see? Obviously, most of you here use distributed file systems, so there's obviously some skew in that, collection of data. But what you basically see kind of in the middle, this is what we see the workloads for people that use data at some significant amount of scale. So there is HPC, there is, distributed object, big data. This is typically the various analytics frameworks you see people using. And, there's a lot of upcoming workload with AI and machine learning. Then around that, you see kind of in this bubble, all these trending technologies that are showing up everywhere. You see things like NVMe, storage class memory. You see people using significant amount of fat nodes. GPUs are basically very pervasive. They've been used everywhere in most workloads these days, or people that basically run analytics leveraging GPUs or any other form of hardware accelerators. So there's a lot of stuff going on this side of the angle. On the other side, we have challenges. People would like to use different interfaces. People want to deploy stuff in container. Some prefer a key value store versus a parallel file system. So others like HDFS. They like the analytic frameworks provided by Yahoo and all these frameworks that are out there. And then when you actually go to the outer side, there is a couple of more issues, and that's where we basically try to focus most of that talk on, which is essentially, it's not going to be very long, it's only going to be 7 more minutes, but I'm trying to basically focus on the I/O specific problems that people see. So I/O behavior, I/O performance challenges that people see, latency and things like that. And then also on the security side, we see a lot of, people's requests on the security side. Multi-tenancy is one very specific thing. And then also on the data management side, and I'm trying to focus a little bit more on that. So I'm not going to go through all the slides because there's just, unfortunately, not going to be enough time to go through all that in very, very great detail. But I think most people here in the room is going to find a lot of issues that they've encountered in their environments that they would like to have a more, native solution that in a futuristic storage system. So one of them that always comes up in the security aspect is all around multi-tenancy. And different people have different viewpoints to multi-tenancy. So some people see multi-tenancy simply as I want to have, lots of different file systems somehow sharing the same hardware. And I don't want the other people to see what's going on in my file system, but I want to get the economy of scale, basically. Other people see multi-tenancy very, very differently. So there is, for example, requests that I came across quite a lot of people who want kind of dynamic views to data. So I want to write a policy, and the policy essentially determines what the namespace looks like. So you don't necessarily have a namespace, which is a file system. You basically have a namespace that gets kind of dynamically built based on policies, based on access control lists, or based on user-provided tags that are basically put into the system. And so you essentially dynamically build this namespace going out. There is a very, very huge focus of people looking into containerization. And containerization means many, many different things. This is everything from I want to run the file system in the container to I want to run the workload in the container. Also, I want to run a workload in a container that accesses a file system that is outside of the container. So while there is a lot of solutions in this space, none of them are really native solutions as part of the storage platform. Most of them are actually afterthoughts. So if you run, for example, file systems inside a container, depending on how you mount them in the container, you lose, for example, access control lists, or you might lose additional functionality the underlying file system provides because there is essentially no control path into the file system that is outside the container that is mounted inside. So these are all kind of challenges that we see. Luckily enough, Lustre, for example, already took some strong steps towards better multi-tenancy support. So with Lustre, you already have the capabilities to mount different file systems or portions of it essentially for individual tenants. And that addresses some of the requirements, but for example, it does not address things like dynamic views and stuff that I described before, where people want to have a more metadata and essentially rule-based driven view into the storage underneath it. So challenges in I/O performance behavior. That's always a really big one. And I think in this area, there's actually some solutions at least. Even some of them are more afterthoughts, some of them are more integrated, and I'm going to talk a little bit more about that. But essentially, you see a lot of newer applications coming up that operate with very, very small and very, very large data sets. So you have basically both ends of the spectrum seem to become more and more extreme. So on one hand, people want to store a massive amount of metadata, and in a file system, sometimes they just do this inside the file system, creating tiny files that represent metadata. Sometimes they have external key value stores, but essentially what you see is that there's some significant shift from pure sequential workload into significant portions of random workload. Especially AI and machine learning is driving a lot in this. And when you look at the announcements we've done around AI 200 and a lot of these solution kits that we provide, they provide solutions that are more driven towards small random I/O performance capabilities rather than just large sequential workloads. And so, as I said, data set sizes change significantly, and there is more and more an emphasis also on the end user side for very interactive behavior of the system. So cutting down latency everywhere where it's possible is something that people are really looking for. So this overlapping I/O problems and conflicting access is one thing that we can very nicely address with IME today already. So there are capabilities in this space. Lux structured file systems, which is part of the IME product itself, is addressing and mitigating some of these I/O write amplification issues that people are seeing. There is a lot of other features in other file systems in GPFS. There's Hawk, there's LROC. You will see Aluxio and other things that are out there that try to accelerate workloads. Again, there is a lot of point solutions for problems, but none of them are really truly integrated into a native end-to-end storage infrastructure. And so I believe there is some more work that needs to be done to make this nicer and more integrated essentially for the end users. Data management. As I said before, I see some significant growth in customers' demand and desire to essentially tag and integrate metadata as an integrated part. So I see a lot of customers using external databases or key value stores. That's where they store a massive amount of metadata, and then they try to create linkages between those and file systems. And it's always a really big problem because you can't really keep the stuff very nicely in sync. There is always, race conditions where things don't end up being linked properly together. And also you see requirements. I came across some requests from a customer a couple of days ago where they seriously ask us how can we store a quadrillion objects in a storage system. He didn't specify, how that storage system necessarily needs to look like, but we would like to store a quadrillion objects. And we need this because this is essentially the amount of metadata we believe we need to store alongside with the data that is stored in the system. And doing this with a normal traditional storage system or the ones we know today is essentially not something you can very easily do. As you probably heard, we acquired a company called Tintri a couple of months ago, and we are very successfully driving this company going forward. They're specialized on virtual machine storage, something very different than what we do traditionally at DDN. But one of the reasons we acquired this company is not just because it has a very, very great product, and we got a lot of very positive feedback from the customers. Tintri is a storage system that I always call it's actually not a storage system. It's essentially a box you have in your data center, but the brain actually sits somewhere in the cloud because the system constantly reports information into the cloud. And then very, very smart analytics that runs into the cloud gives you constant insights into what the system is doing and how you constantly can essentially enhance and improve on it. And so we try to take this technology and develop this as an even bigger scale and make it an integrated part in essentially everything we try to do at DDN, drive everything with analytics and based on data and not just have this as kind of an afterthought in the system. So conclusions. You know, we already make very strong inroads into a lot of these data challenges with the roadmap. Some of them you already heard, some of them you're probably going to hear in NDA sessions if you set them up with the individual people in the various product. We have a very heavy investment in engineering ramp up. I'm basically interviewing people constantly since I've joined, and we have a very significant ramp up of engineering skills, always towards analytics and all these futuristic things. And we actually have a very interesting secret demo. So if you're interested in that, you need to sign an NDA and you should talk to somebody at the booth about some of the things that we're planning to do in the space. Thank you. That's the end of the presentation.